Right, so before I was interrupted. So, just in case it's not obvious what's going on here, basically these are 450 volt batteries, and I have a meter on one of them, and it's turned off. That's good. Not really. There we go. And it's currently at, well, okay, they're 400 volts basically, and that's at 433 volts. All three are about the same voltage, 433 volts. Okay, right now. So we're using, as you can see, there's the circuit comes in. Oh, let me show you that side just in case you think I'm cheating. So you can see there's the mains. It goes into it. This is a 1-to-1 isolation transformer. There's no step up. You can see. So that's 240 in, 240 out. Okay, because you can see it's on the 240 volt terminal. Yeah, and it's 240 in obviously. Probably safe mains wiring, not really. Doesn't matter. Okay, so this is just all this is doing is just so that I'm working on this safely. That's all. You could plug that directly into there, and it would work the same. It's just that you'd have a live chassis right now because of the earthing there. That's obviously not going to be in the production vehicle. Okay, so you can see there we've got the isolation transformer, which is providing to this socket block to 240 volts. So the isolation transformer is obviously not necessary in this circuit. You could plug that directly in, but we're not doing it for safety's sake right now. And you can see 3 white cables. All 3 white cables are going to these circuits. So what's going in at that kettle lead point is 240 volts AC. Okay, so we've got 240 volts AC on this side, and the battery is a 400 plus volts battery. So how can you charge a 400 volts battery from 240 volts AC? Well, you cheat. So these capacitors here are part of a Dellen circuit, which is a doubler, a voltage doubler. So that's 240 volts AC on one side, right? Well, the peak voltage is around 340 volts. So the peak of the sine wave is 340 volts. Okay. So you've got 340 volts going into the 340 volts peak going into the Dellen circuit, so out comes 680 volts roughly. Okay, now if you was obviously to connect that directly, then you would end up with a shitload of current and blown circuits, and of course that's not what that's no good. However, right, so originally what I was doing was I was actually reducing the voltage using an auto transformer. So I was bringing the voltage down, right, and then tuning it to provide a certain amount of current. Okay, so the auto transformers were bringing the voltage down so that you could then do it. Well, what's happening is the triac that's in that circuit is doing the same thing, right? So we've got, basically this is an Arduino, of course, and what that does is it detects when the waveform crosses the 0, and then it holds the triac off, right, until a preset time, which is set by software right now, and then it turns it on, and you're altering that phase angle, what's called the phase angle, right, to increase or decrease the amount of average current through into the Dellen circuit, right? So what you're doing is on the AC side of the Dellen circuit, you're tuning the phase, which means on the outside of the Dellen circuit, you're just varying the voltage, because it's a charging circuit, and all you're doing is changing the rate of charge of this circuit, and the discharge is into the battery, you see? So you're altering the charge and then the discharge. So what happens is that you can start off with very little, right? So it's basically waiting almost the whole phase and then a little tiny bit as if it were. So you've got a little bit of charge going into the Dellens, right? Which means only a tiny bit of current. In fact, it won't, because there's not enough potential, right? And then as you increase the phase angle to provide more and more phase, right, you end up with more charge going into the Dellen circuit and more charge going in the battery, and that's how you vary the charging rate. It's pretty straightforward, not rocket science, and that's how it's done. See? And the phase angle is varied using software. Right now it's just manually I'm adjusting it, just, you know, and seeing the current. But what we're going to do is and I think this is the way it's going to work. This is a Raspberry Pi. So on the Raspberry Pi, we're going to have an MCP chip, which is the same MCP chip that I've got in this circuit down here, which you might be just about seeing all the wiring. Yeah, that black chip there. So that's an ADC. So that means you can have an analog input into a Raspberry Pi. And MCP chips, the one I've got is an 8-channel one, right? So you've got 3 channels for the voltages and 3 channels for the currents. So you can measure it, and then using software on the Raspberry Pi, you can adjust the output of these circuits so that you've got, you know, a particular charge rate. So the whole system, and that's how the whole system will basically work. Okay. Yeah. And the reason why I'm using an Arduino rather than maybe connecting directly to the Raspberry Pi is because it's just easier to develop like that. Although I might be able to actually just directly connect into the Raspberry Pi, but then I'd have to develop a program which can then meter all 3. I don't know. I might do that. Don't know. Not sure. But right now it's easier to do it like this because then you've got an isolated unit which is controlled using logic. So, but this is working. We've got all 3 on. The fuse that's on it is a 3-amp fuse. You see. So I'm not obviously going over. This is on the AC side as well. So we've got less than 3 amps going in, which means we've got less than 1.5 amps going out. We have, because I've tuned these down to about 0.5 amp just to test them, basically. Now, the thing that's missing right now is there's no heatsink on the Triac or on the bridge rectifier. So I might do another version of this circuit which has heatsinks on it. I'll remove the control as well because that's not necessary. I use that just to tune, you know, manually tune the voltage, the phase angle, whereas we're doing it in software now, so I can remove that. So I might do another circuit like this where it's just the components, and also we have mounting so that we can check the temperatures. Yeah, the capacitors are cold. I think that one's on 1 amp. Let's have a look. Gotcha. Where is the... Here it is. Let's have a look. Okay, let's have a look. So 0.6. I think I always check both sides because okay, it's slightly lower on that side. Doesn't matter. It's a bit asymmetric, but that's on 0.6 amps now. And these are less than 0.5 amp, I think. No, that's actually quite low. 0.13. There you go. 0.4. Yeah, 0.43, and then this one, which is there's nothing there. They tend to be a bit asymmetric because of the charging rate. Oh, nothing. Huh. So that one actually isn't charging. It's possible because it's actually reached the charging voltage. So I'm monitoring the voltage of the batteries here. There. And as you can see right now. So that's reading slightly high. It reads about 10 volts high. Okay, so we're talking about 437, 438, 436 volts. Okay. These are the 3 charging circuits, as you can see. They're running, and this here is the important bit because that's detecting, that's showing how it's detecting the input, the phase, so that it can trigger the Triac. If we get a 0 there, or something other than 10, then something's wrong with the AC side of the circuit. Usually the fuse is blown. Yeah. Yep. So it's working. Cool. And I need to tune one of them. I don't even know which one it is now. To increase its power output. Maybe. Don't know. The thing is, the battery on this side is actually charged. So I don't actually need to put any power in it because it's already fully charged. All I'll be doing is just offsetting the internal discharge. Yeah. So the next thing is basically to put these things to make a module that fits in there with these things in and a Raspberry Pi perhaps. and instead of, because this is a 12 volt power pack that I'm just using for testing, but I can equally well take the 12 volts from the 12 volt circuit and power it from that, just like the other one is, and that one at the front. Yeah. So yeah, cool. That looks cool, doesn't it? Look, there you go. And you can obviously see how these would just be mounted and they could just go into a unit that's there, all of it.